Hi, good evening, everybody. This is Dr. S.B. Paul from Genesis Technologies, Mumbai. As I have committed earlier that I am going to talk about various simulation and models available on climate change research and studies on Environment Day. There will be altogether 8 lectures, and each day I am going to talk about one technology. Earlier I have covered the importance of Environment Day and what we are doing exactly as a company. I also told there are altogether 8 lectures that will be covered, which is going to cover the whole aspect of climate change research, the objective, and many more things. Today is my first lecture after my introductory part, as I have given in my earlier presentation or my lecture. Today I am going to talk about a technology that is a very important technology for crop simulation model, that is open top chamber technology, or you call it real time elevated open top chamber. Those who are from the biological background, they were aware of growth chambers, whatever experiment they do in the laboratory condition, and they expose those plants inside a growth chamber. You call it plant growth chamber, and inside the chamber you monitor and control certain parameters like temperature, light, CO2 level, humidity level. Those are the basic 4 parameters that usually is been maintained inside the chamber. But there are certain limitations in plant growth chamber because it is not exposed to environment, it's a closed system. So whatever experiment you do it on climate change studies, you are supposed to carry out those experiments in open conditions and want to see the impact of various parameters, what I have told. So from plant growth chamber or growth chamber, we are taking one step ahead. We are making a chamber, simulation chamber. You call it open top chamber. It is made of iron structure. The size of the structure, it can be 4 meter, 5 meters, 6 meters, 7 meters, 7 by 7 maximum height, 4 meter, 5 meter, 6 meter you can go based on the kind of crops you are growing inside the chamber. I am going to talk about one chamber first, then I will talk about the experimental designing part. Let's think for a chamber. A chamber, either it can be a circular, it can be a square, or it can be hexagonal structure, and it should be grouted properly in normal soil conditions, and it is covered with polycarbonate sheet, 4 to 6 mm polycarbonate sheet, multi-layered polycarbonate sheet. It's 85% light transmission, one side or both side UV coated, UV protection facilities can be given, and the structure top portion is totally open. Now the question is, now this is a chamber, this is a structural part, it has got a door for entrance, and normal soil can be used for cultivation of crops. So this is basically the experimental plot that you are thinking. Now, as I have told you, this is the structural part. Once the structure is done, then the coming back to the instrumentation part. So based on the objective of your research, you can have few parameters, that is for monitoring and control purpose. Most of the climate change research is based on, you want to control CO2, you want to control temperature, maybe you want to maintain the humidity level, you want to maintain the moisture level, or you want to monitor the moisture level, or you want to monitor the humidity level. So based on that, even for the soil moisture, soil temperature, and the power, the photosynthetically active radiation, that is also one of the parameters that can be monitored throughout the crop season. Now, to do that, you need to host or assemble those monitoring or control system inside the chamber. So for temperature sensor, you can use PT100 sensor with a transmitter having 4 to 20 milliampere output option. You can have humidity monitoring system also, that is the humidity sensor, and you can have CO2 monitoring system. You can put the CO2 analyzer or CO2 monitor inside the system. Even for the soil moisture, soil temperature, you can have respective probes that is been mounted, and you can prepare a console of box with a transmitter, everything to be mounted. The weatherproof box you can mount it. Now this is the sensor part. Now as I have told you, any chamber that what you are developing, your objective has to be defined. Either if you want to only monitor or control CO2 and temperature, enrichment for those two options, and there must be some CO2 discharging facilities also inside the chamber. And for temperature, what we are using top mounted infrared heating system, ceramic infrared heating system. If you want to have temperature to be controlled ambient plus 2 degree or 3 degree, that can be done. So this is all about one chamber. Now, to carry out any experimental design, you need to have minimum 3, 4 or 5 chambers. First of all, your ambient is the reference, that is uncovered part where you are monitoring the similar kind of or similar simulation environment that what you are creating in natural condition. You are taking those parameters and also growing plants there. This is the reference, and from that temperature reference you want to control ambient plus 2 degree. Even for the CO2 also, for CO2 monitoring system, as I have told you, generally on climate change research we use IRGA or IR based system, infrared NDIR that you call it, non-dispersive infrared system for sensing the CO2 gas. CO2 gas is normal ambient condition, you have 380 ppm to 400 ppm. Now this analyzer should have the capability to analyze CO2 from up to 3000 ppm, because those kind of chambers you can use maximum 700-800 ppm CO2 level, because beyond that generally it is not required, because for the prediction, if you think of analyzing or exposing plant in 800 ppm CO2 level, it is too much prediction. So basically you need to restrict your CO2 exposure to plants up to maximum 600-650 ppm, not beyond that. So now coming back, the set of experiment what you want to do it. If you are working on only CO2, the effect of CO2 studies, you need to have one ambient which is controlled reference, and one OTC you need to develop it, where you are not exposing with CO2 level, and another OTC that you are doing it for 500 to 550 ppm, and another OTC you are doing it for 600 to 650 ppm. So basically you need, if you want to have only CO2 studies, you need to have minimum 3 OTC. One is the ambient control and one is the OTC, we are not exposing the CO2, that is also controlled, and 2 different level of CO2. Now imagine a situation, if you are growing similar kind of crops in 4 different conditions, and you are going to observe the variations what is coming out in different exposure of CO2 level throughout the crop season. Most of the time you mostly working on seasonal crops, so it 3 months time probably for the experimental exposure and everything for CO2 purpose you are going to do it. Now this is one set of experiment as I have told you. The other thing, if you want to see the combined effect of CO2 and temperature, then you need to increase the number of OTC. Now you can have the replica of each treatment 2 to check the variation and other things, whether things are happening on your expectation basis or not, so that you can have replica of the same treatment, so that you need to have, let's say 650 ppm. The another system also you can use it for 650 ppm. If you want to work on 700, another also the 700 ppm to 650 ppm, and you have one control and one is reference control. So that way you can do it. Now as I have told you, if you want to work on temperature, so your experimental designing should be such a way, you have one ambient control, one control, one CO2 level, ambient plus let's say 200 ppm, another is like 380 ppm plus 200 ppm, another is 380 plus 300 ppm. Now the temperature part, you can have one OTC only with temperature, another OTC with temperature plus CO2. Now temperature is not going to work with you. You have to have ambient plus 3 degree, another OTC ambient plus 5 degree. So if you want to have the combined effect both for CO2 and temperature, then you have to have both CO2 plus temperature, one level you can decide either 600 ppm CO2 plus temperature ambient plus 2 degree, and another set of experiment that what you are doing it for CO2, let's say 700 ppm and temperature ambient plus 5 degree centigrade. Now Probably this thing are clear. Now the question is here, your number of OTCs that is increasing. In the same OTC, you can carry out only a specific temperature and a specific CO2 level. So, and accordingly your set of experiment will be done. Now again coming back, if you want to work on CO2 and temperature, then your experimental designing, again I am telling, one will be reference, one is ambient, one for one CO2 level, another for one CO2 level. It can be 600, the another can be 700, whatever CO2 level you want to decide. This is 2 CO2 level, 2 temperature level and 2 CO2 plus temperature level. So accordingly you can calculate the number of OTCs required. Now another parameter that is very important, the ozone part. Now in climate change research, apart from CO2 temperature, ozone also is impacting because of the global warming, ozone hole, very other things are like, no, in normal atmospheric condition your ozone is there from 40 ppb to 60 ppb based on different location, different area. Now ozone level is increasing. Now you want to see the impact of also ozone, what is happening with the plants. So similarly your experimental designing to be also incorporated, like, no, with ozone of different levels. So your set of OTCs, open top chamber, also is going to be increased. Now all those OTCs are having the instrumentation based on the kind of exposure you want to do it. Let's say if any OTC you want to use it for only for CO2 purpose, the important part is you should have CO2 monitoring system and control system, or you can have all the sensing facilities available in all system and you can do all kind of permutation and combination the way you need it. Let's say if you do not want to work on CO2, you don't expose to plants into elevated CO2 atmosphere. If you do not like to work on temperature, you can eliminate that part, but you can always make such kind of provision while developing this system. Only thing, during the experiment probably it is your choice how to include, whether to include it, whether to exclude it. So coming back, what is the objective of all those research? Because when you are treating plants in different climatic condition, you are exposing plants into various treatments like the temperature, CO2, ozone, exposing plant. For ozone, you need to have ozone monitoring system, even the ozone generator. Now the question is, all the instrument should be taken into a platform where you can have controlling action, data logging action, data monitoring option, so that every minute or every 5 minutes you can have those data logging, data monitoring facilities. You can see it, and each day data can be generated on Excel databases. So you can literally see that how this is happening. Generally you can use the SCADA PLC platform for monitoring control purpose, and this is a very critical system, that this is the heart of the system. This is very important to have when you have, let's say, signal. If you are working on 10, 12 or 15 OTCs, all the signals are coming into your PLC through data logging, and you need to do complete instrumentation so that the signal loss, data loss is not happening and proper controlling action is done. Accordingly, your hardware, software has to be developed properly. As I have told you, developing the hardware part or developing the system, wherever you want to expose those plants into CO2, there will be proper CO2 developing system or CO2 releasing facilities. Generally we use CO2 tank or CO2 cylinder. Through a manifold, you can take out the CO2, and through a compressor, through dilution, because CO2, it comes with a pure CO2 level from the CO2 tank in a high pressure. It's a 60 kg pressure when CO2 is there inside the tank. It is in the liquid form. When you open the regulator with certain pressure, when it exposes, it comes into the gaseous form. So from liquid to gaseous phase, but it is 99.99% pure. So it is very important to dilute those CO2 with air. So whatever ratio you want to decide, you can decide 10:1 or 9:1 ratio or 1:1 ratio, whichever way based on the concentration, and you can dilute it, then you can release it. As I have told you, the software part is a very important part, that is the heart of the system. In the computer, what is more important, and essentially you need to see the system is having all kind of, let's say you have 10 OTC, all those signals will come into the OTC. You can literally see what is the level, everything will be shown. Now you configure the system in which OTC, what is the level, what is the temperature, or what is the ozone level you want to monitor and control. Once you set your system, you can operate throughout the crop season based on your set point. So it is a fully automatic system. You need not manually do anything. So it has got a solenoid. Let's say imagine a situation in a particular OTC, you want to maintain 600 ppm. It is operated through solenoid valve. So basically when you have the CO2 sensor mounted inside the chamber, it actually checks what is the existing CO2 level. If it is lower, let's say if it is 400 or 500 ppm and you want 600 ppm to be achieved, so automatically solenoid valve will be on and it is going to purge or release CO2 till it achieves the 600 or 650 ppm. Then automatically once it attains that particular CO2 level, it is going to be stopped. On climate change research, it is very, very important, whatever level you want to decide, throughout the crop season that level should be maintained. Similar way for temperature. Let's say imagine a situation you want to have ambient plus 2 degree or 3 degree temperature to be monitored and controlled with reference to ambient. Now you have ambient temperature sensor. It is giving the signal to the system and telling that what is the existing temperature level. Similar way, inside the OTC, whatever temperature level is there, it is also giving the signal. Now you want in ambient, let's say ambient it is 30 degrees centigrade, but you want ambient plus 3 degree temperature to be achieved inside the OTC. What is actually doing it? It is going to measure the outside temperature when it is 30 degree and you want to have 33 degree or 34 degree temperature to be monitored. So it is giving commanding infrared heaters to be on, and it is going to achieve, once this infrared IR heater is on, it is going to attain plus 4 degree, and after that heater will be off. So in this process your temperature is maintained, and this is a kind of a repetition throughout the day or throughout the season. The same process can be continued. Now there are few things that we need to understand. This is a complicated system. All system, when it is operational, all should be functional. So there should not be any sensor faulty. If it is a faulty sensor or anything, so you are not going to see that particular chamber, whatever required data, what you are expecting for CO2 release or temperature release, whatever things, it is not going to happen. So you need to check that all the sensors are functional, all the hardware are functional, all the data what is coming, it is coming to the respective channels. So there are few things that is we need to have in mind. Let's say you have 100 signal that is coming to the PLC, and it is some are doing data logging, some are doing the controlling part. There are various job based on the configuration you can do that. But what I am trying to tell you over here regarding the signal transfer or transmission, there are various ways you can do it. Either it can be done wired or wireless system. If it is a wired, so you use the all sensors whatever you have, you take out the 4 to 20 milliampere output option or 0 to 10 volt DC, and whatever output option you have you put into the PLC through a wiring system. Take a cable tray and put into the PLC through data logging. This is one way of doing it. Another way of doing it is you can use the wireless device. It is the wireless communication system. You put each device into each OTC so that all the signal can be transmitted up to 150 meter or 200 meter signal can be transmitted to the control room, and there will be receiver that receive the signal and give feedback to the PLC. Accordingly you can do the control and automation job. This is more reliable in long term. This is little expensive, but this is reliable because your data loss, signal loss is not there. And another thing is, when you are using this kind of wiring system wireless, throughout the year goes, like after 1 year or 2 years you will see that there will be a cut because of rat bites or many other environmental factors, there will be damage. So in order to avoid that, the wireless communication system, or you call it Wi-Fi communication system for instrumentation, this is not the normal Wi-Fi what we use it for our mobile and other things. This is a different Wi-Fi for the instrumentation purpose. We use it and get the data into the control room, and it can be also hosted to the website, and you can prepare app from there. Also you can have controlling monitoring facilities. Different user can be given different password so that in various level and various protection can be made. That is for the to make the system user friendly. Now what I am trying to tell over here, open top chamber system is the best way to do research on different crop varieties and to develop different crop varieties to mitigate the food crisis and various other things. This is a good simulation established model, and we have developed close to 50 projects across India. Those projects mostly covering all ICR Research Institute, CSI Research Institute, DST, agricultural universities, central agricultural universities, IITs, International Research Institute, and you name any research organization in India, we have developed such kind of system. So open top chamber system can be used for various crops, vegetables, covering wide range of things like rice, potato, wheat. Some are using different Tectona grandes, legumes, non-legumes. So it can be regional based, any kind of crops you want to grow it. The main objective of open top chamber simulation model is going to help to develop various varieties As I have explained in my first presentation, that what is the need of those kind of simulation model and how those simulation models are going to help. As I have again told you, because of global warming, your CO2 level is increasing, temperature is increasing, ozone is increasing. The kind of crops you are growing today, maybe in this particular condition, whatever crops are growing, if it is elevated condition, if suddenly CO2 level goes high after 20 years or 30 years, the kind of crops you are growing is not going to give you such kind of productivity, and so that you are going to develop such kind of germplasm which are capable to withstand such kind of environmental factors which is expected to come and what we are predicting today. So it indirectly is helping to mitigate the food crisis, and even for the temperature also, and the for ozone also. So you develop the germplasm which are adaptive to those kind of environmental factors what I have referred. So it is important to know throughout the world it is happening such kind of research. So I have visited several countries. I have seen how open top chamber technologies is being used for developing the varieties. Israel is doing, South Korea is doing, Japan is doing, US is doing, the Brookhaven National Laboratory, UK is doing. So there are many countries, Finland is doing. So all universities, agricultural universities, they are conducting various research experiment and they are developing various varieties. In India, the institute like Kharagpur IIT, they are working on rice. They have developed various rice varieties in these climatic conditions. OUT, Bhubaneswar, Central Rice Research Institute, Kotak, they are also working on rice. Tamil Nadu Agricultural University, they are doing various projects, both temperature and CO2, and they are also working on rice. So even for Central Potato Research Institute, they are working on tubers like potato and various other tuber crops. Again, Dehradun, that is Forest Research Institute, then FRI, they are working on trees like Soria robusta. We have developed a big OTC for them. Assam Agriculture University, they work on rice. Beyond that, they also work on different spice. So those systems are developed long back. Beyond that, we have developed system for Hyderabad University. Went down south. Also, Bharatiya University, they are working on Tectona grandis. So, like that, there are many institutes. They have taken various crops. University of Dubai also, they are working on rice and various other crop varieties. So what I am trying to tell over here, across the globe, whatever system we have developed in India, certainly those systems are functional and we are giving them system support, technical support, and keeping those systems functional. I think there is nothing more to say about the OTC, and in future if anybody is looking out for certain kind of system development, system integration, system designing, we'll be happy to help you. Again, The technology part, it's complicated. It is better to understand the application part, the objective part, and the system what we are developing for you. It's reliable, it is workable, and it's a functional system for you. So there are many research paper that has been published. There are many postdoc students. And there are many varieties that is developed from those OTCs. So those things are in public domain. So thank you very much for listening this small presentation or small talk. And if anything, please revert back to me. I will be happy to help you. Thank you so much. My next presentation, I am going to talk about free air CO2 enrichment technology and free air temperature enrichment technology and free air ozone enrichment technology. So till then, bye bye, good night, thank you very much.